Web pages rendered in browsers have long been the most ubiquitous method for end users to obtain information from and interact with the content on the internet. For human beings, it is natural to identify the region of web pages that contains the most interesting content and group visual elements that bear similar semantics and functions together. However, it is not so easy a task for machines to complete automatically. Web page segmentation or fragmentation refers to the task of automatically splitting the web page into different regions of the web page that are semantically and visually coherent. To complete such tasks, programs need to have a basic common sense understanding of the visual and functional semantics of the text, images, and interactive widgets shown on the web page. The downstream tasks of web page segmentation include automatic web application testing, automatic screen reading, and web information retrieval. To the best of my knowledge, there is no existing work that trains neural networks to accomplish this task. In this project, I trained models of 3 different network architectures for web page segmentation and compared the performance of the trained models to the previous works. For this project, I used the WebEase WebSec 20 dataset, which contains 8,490 web pages and the corresponding cross-source web page segmentation annotations as ground truths. I split the dataset into a training set, a validation set, and a test set containing 7,646, 422, and 422 pages respectively. The 3 neural network architectures I trained are the Hybrid Task Cascade Network, the YOLO-X network, and the faster RCNN network. I trained 3 models on the web page screenshots, the coarse edges of the screenshots, and the fine edges of the screenshots for the Hybrid Task Cascade Network. The YOLO-X network was trained on the web page's screenshots. For the faster RCNN model, I created 2 modified network architectures by removing the region of interest head of the faster RCNN model and increasing the base anchor configurations of the network. I then trained the 3 faster RCNN networks on the screenshots of the web pages. Because there is only one class of object in the web page segmentation tasks, we may not need a region of interest head for object classification and another round of bounding box regression. I hope that by removing the region of interest head of the faster RCNN model, the model can have shorter training and inference times. Also, the original faster RCNN paper shows experiments demonstrating the importance of multiple base anchor configurations. I hope that I can improve the performance of the model by adding even more base anchor configurations. The experiment results are very promising. I measured the performance of the models in terms of the extended B-cubed F1 scores, which is the metric proposed by Kiso et al. In the paper Web Page Segmentation Revisited, Evaluation Framework and Dataset. The YOLO-X model trained on the screenshots of the web pages is one of the best performing models, exceeding the baseline algorithms and other algorithms reported in previous work in most, if not all, scores measured. The vanilla faster RCN model and the faster RCN model with increased anchor configurations also perform really well while taking much less time for training compared to the hybrid cascade models and the YOLO-X model. The faster RCN model without a region of interest head performs pretty poorly, probably because of the removal of the second bounding box regression layer. The faster RCN model with increased base anchor configurations performs better than the vanilla faster RCN model, while it takes slightly more time for training and inference. In general, the project shows it is very practical to incorporate trained neural network models in applications that require web page segmentation. In future work, it may be worthwhile to investigate the relationship between the segmentation performance and the probability score threshold used to filter generated segments. Thank you for watching this video. Please refer to the project report for the details of this project. You are welcome to email me if you have any further questions.